All right, class. So we're going to do the second side of our chapter 13-5 notes. Okay, and they're mainly just examples. So let's get to it. If you need the guidance, please listen along. So determine whether each events are mutually exclusive or not mutually exclusive. Okay, and I talked to you guys before. You could just ignore the word mutually. Kind of confuses people. So are they exclusive, which means they don't share things. They don't share. And this one, they do share something, okay? They have copies of each other. All right, so selecting a cat or dog at the animal shelter that has 15 cats, 25 dogs, 9 rabbits, and 3 horses. Okay, so picking a cat or dog. Okay, so this here is a mutually exclusive event, okay? Which means that, there are no copies of each other. So if I were to do my probability here, it would be probability of getting a cat or probability of getting a dog. Side note, this symbol, you can use it interchangeably. You could have wrote it like that, or you could have wrote it with the U, right? The probability of cat or dog, right? Just math notation, that's all it is. So remember, or is more, okay? Or means more. When we talk about more, is addition. So what's the probability of getting a cat? It is 15 over 52. The probability of getting a dog, 25 over 52. Okay, and there's nothing you subtract, right? For mutually exclusive, you don't subtract anything because they don't share. There's no copies of it. So this here is 40 over 52, which is 10 over 13. Okay, I know it says round to the nearest tenths, but you don't have to, or at least for these notes. Next, rolling a 6 or an even number. Okay, so remember, or is more. Okay, you're adding the probability of getting a 6, or okay, I did a U shape. Okay, or getting an even number. So let's think about that. Are these mutually exclusive or not? Okay, is there a copy of each other? Right. To roll a 6 is a 6. To roll an even number, you can get 2, 4, or 6, right? So they do repeat, which will make this not mutually exclusive. Okay, so let me just write that over here. Not mutually exclusive, okay? Because they share something, okay? They have something in common. So the probability of getting a 6 is 1 over 6, right? Rolling a 6-sided die. The probability of getting an even number is 3 out of 6. But now you gotta make sure you subtract the copies. Okay, so here's a good way to remember. Like not mutually exclusive, there's a minus sign, right? Like it's negative, not. So not mutually exclusive, you have a minus sign because you're getting rid of the copies. And they do share the 6, right? So if they share the 6, you can't count it twice. So you subtract one of the copies. This equals 3 over 6. Okay, it's still just 1/2, right? The probability of this is the same as saying the probability of getting an even number, right? Okay, number 3. According to the table shown to the right, what is the probability that a person on a student council committee is a junior or on the service committee? Okay, so let's think about this. How many juniors do we have? Juniors, 10 to 16. How many sophomores? 8, 11, there's 12. 18 seniors, okay? So I only care about that, the juniors, and the service committee. Where's the service committee? Right here. Boom. Okay. So, service committee, there's about, 15? Okay. But remember, you're counting them twice, right? So this is where the intersection, that 5, right? You gotta subtract that because you're counting it twice, right? Because the total isn't 16 plus 15, right? That's 31. So let's kind of show the math here. So the probability of being a junior, or, that usually means or on the service committee. So probability of being a junior plus the probability of the service committee minus the probability of being a junior and like the letter N and the service. Okay. So really just, in your head, right, if you want to think about it, you're going to do 16 plus 15 minus the duplicate. So it should be 26. And let's see if that math works out. So it should be 26. Probability of being a junior, 16 out of what? Oh shoot, what's the total? The total looks like it is 46. It's going to be 46. All right, add them all up. 46. Okay. 16 over 46 plus the probability of on the service is going to be 15 out of 46 minus the probability of being both, right, because you're counting it twice, is 5 out of 46. So this would get me 26 over 46. Boom. Okay. All right. So hopefully that's pretty good. One slightly new concept is the word complement. Okay. Complement, not compliment, or I don't know. Okay. So complement or compliment is when you compliment yourself, right? Like the I and the E, right? Like you give a compliment to yourself. That's when it's like a comment to yourself. But complement is deals with probability. That is when you have an event A, right? So event A, if I do 1 minus the probability of event A, the complement of that is not A, right? So if something, it's pretty simple. If something has a 9% chance of working, what's the complement of that? 10%, right? If something has a 3 out of 5 chance to work, well, what's the chance of it not working? The complement of that, 2/5. Okay. Ultimately, they should always add up to 1 whole. Okay. And reminder: this one represents what percent? This one represents 100%. Okay. So let's do a quick example here. A school has a photography display of 100 pictures. One of the pictures will be chosen for display at the district office. Lorenzo has 3 pictures on display. What is the probability that one of his photographs is not chosen? What the heck? That's weird. Is not chosen. Okay, so not chosen. So the probability of picking one, though, is what? What's the probability of actually picking one of his pictures? Is 3 out of 100. So if it's 3 out of 100 to get his picture, what is the probability of not getting his picture? It would just be simply, right, it would be 100 over 100. You want to think of it that way. Minus 97 over 100, which is 3 over 100. Yay. Which makes sense because that's, what the heck is my math? There's a mistake. I'm going too fast. Probability of A, right, it's not likely because he only has 3 pictures. So the answer is actually 97. Sheesh. Sorry, guys. My mind is going crazy. That's your answer. This is the probability that one of his photographs is not chosen. Right? Not chosen. Okay, why don't you guys try out 1, 2, and 3. Actually, I'll do 1. You guys can do 2 and 3. 4 is a challenge problem. You can try that, but we'll do that together. Okay? So, for number 1, if there is a 4 in 5 chance that your mom will tell you to clean your room today, what is the probability that she won't? Okay, well that's easy. The probability of not telling you to do your chores is 1 minus that, which is then 1/5. Okay. Try 2 and 3, okay guys? And we will check with each other. Alright, let's take a look at number 2 here. What is the probability of drawing a card from a standard deck and not getting a spade? Okay, you draw 1 card and you do not want to get a spade. So first off, just find the probability of getting a spade, right? That's 1 out of the 4 suits. So that's 13 out of 52. So you subtract that from 1. The probability of not getting a spade is 39 over 52. Okay. Number 3, what is the probability of rolling a pair of dice? So that's 2, you're rolling a pair of dice and not rolling a 6. Okay, so this here is a bit tricky. So not rolling a 6, I think that means the sum of it, right? So this problem isn't as thorough. Just make sure it's the sum of rolling a 6, right? So here are all my options here of getting a 6. You can roll 5, 1, 4, 2, 3, 3, 2, 4, 1, 5, right? So the probability of rolling a 6, I'll be sure on like your tests and stuff, I'll put like the sum of not rolling a 6, right? So the probability of getting a 6 is 5 over 36. So what you have to do with that is subtract that from 1. So probability of not getting a 6, right? You just do 1 minus 5 over 36, okay? And that should get you 31 over 36. All right, last one. It's a challenge one, okay? So please pay attention here. In a group of 5 people, find the probability that at least 2 of them have the same birthday. Okay, so 5 people, same birthday. So here's a hint. You have to use kind of like the complement here. So these people that have the same birthday. But an easy thing to do is the probability of having all different birthdays. Okay, so you have to work backwards with this. So like 5 people, right? How many days are in a year? Let's not include leap year. So it's 365 days. Okay. This first person has how many options to pick from for like the birthday? You don't pick your birthday, but let's say, right, the first person, it could be any day. The second person, right, if they're all different birthdays, they cannot have the same birthday as the first person, so that's 1 less day. The third person cannot have the same birthday as the first 2, so you have 2 less days. And so forth, right, all the way into minus 5. So all the way to 3, 6, 1. Okay, so it's a crazy big number. So again, this here is the probability of every single person having a different birthday. Okay, so 365, right, minus 1 can't be the same, minus 2, minus 3, minus 4, okay? So first person, again, can have any day and so forth. Multiply this together, a little mental math here is actually 0.9728, which kind of makes sense because that means you have a 97% chance that those 5 people have different birthdays, okay, which is very likely that they will be different. So the probability that at least 2, so greater than or equal to, have the same is basically the complement of that. All right, so there's gonna be 1 minus the probability of them being all different, which will end up being 1 minus 0.9728, which then equals 0.0271, aka about 2.7%. So the chances of somebody having the same birthday, like at least 2 of them out of those 5 people, is about 2.7%. Okay, which actually seems kind of high, to be honest with you. But you have 5 people. Okay, 5 people, and somebody within those 5 having the same birthday. All right, that is it. Have a good rest of your day. Hello, teacher of the year. I'll pause this video. Bye, guys. Good job. Keep working hard.